Okay. So, what do you think the equivalent equations are going to be when we go to 4 dimensions? So here's our 3-dimensional equations.
So I think there'll be 6 equations, and there'll be you have to add the x plus the w, y plus w, and the z plus w.
Okay, so one generalization could be 6 equations. Can you think of a different generalization?
Well, you could add w's onto these equations.
Okay.
And then you could create.
So we could have equations that have 3 variables in them.
Yeah.
And how many would there be then?
So you have wxy, wyz, wxz,
There'd be 4 of them.
xyz.
Okay, so there might be 4 equations. What I thought was the generalization was this one. Because here we have 2-dimensional equations.
Mm-hmm.
In 1 dimension, I think there would just be I think there would just be 2 equations. Absolute value of x is less than or equal to 1, and absolute value of y is less than or equal to 1. These are 1-dimensional, forming the boundaries of a 2-dimensional shape. We talked about what does absolute value of x less than or equal to 1 look like?
It's like, well, absolute value of x equals 1 is sort of this V shape.
Draw out for me. Absolute value of x equals 1.
Like that.
Which is the x-axis?
This is the x-axis.
Okay.
Okay, then. That's absolute value of y. Wait.
You're right that shape is related to absolute value, but that shape is not absolute value of x equals 1.
Well, this equation becomes, it's either x equals 1 or x equals minus 1.
Okay, so what does that look like?
So it's actually going to be like that.
Alright, so what do you think absolute value of x less than or equal to 1 looks like?
It's probably...
Okay, and how about, what do you think absolute value of y less than or equal to 1 would look like?
Well, if you had these 2 lines going like this,
Okay.
if they were 1, then it would fill in this space here.
Alright, and how about what part satisfies both of those equations?
We have this part here, square.
We have a square. So we have 2 equations giving 1-dimensional lines, gives us a 2-dimensional intersection. Okay, 1-dimensional lines is boundaries.
Yeah.
And here we have 3 equations giving 2-dimensional surfaces as boundaries.
That makes a 3-dimensional shape.
That makes a 3-dimensional shape. Here, for the project we're going to look at today, we're going to have 4 equations
of 3-dimensional lines. Or 3-dimensional, or... Yeah, 3-dimensional, like... spaces, I guess.
Absolute value of x plus absolute value of y plus absolute value of z is less than or equal to 1. Absolute value of x plus absolute value of y plus absolute value, what do you want to call the 4th variable?
W.
W, yeah. That's fine. Absolute value of x plus absolute value of w plus absolute value of z less than or equal to 1. And then absolute value of w, absolute value of y plus absolute value of z less than or equal to 1.
It's 4.
Okay, so now, before we look at this at all, what do you think that the shapes are going to look like as we take this 4-dimensional shape and pass it through 3 dimensions?
Well, I think, for sure that this equation is going to be a cube here.
Alright, so you think this will be a cube.
That one's it's going to make a cube.
Okay, what makes you think that'll be a cube?
Well, you have the x, y, and z. These are all the the three-dimensional. This is entirely three-dimensional. This is the only entirely three-dimensional one.
Okay.
So it'll form a cube.
Okay, you think that one will be a cube, okay.
Well, how are we gonna look at this passing through? Are we gonna look at it like standing on a corner like we did with the cube?
Ah, very good question, actually. So what I'm going to do is I'm going to fix slices where W is fixed. So what's the smallest value that W can take in all of these equations?
0.
Not quite.
Well, the sum of the absolute values of these three has to be less than or equal to 1.
Right.
So I guess the smallest W can be is -1.
Right. So W is going to range. -1 is going to be the smallest. What's the largest going to be?
Probably 1.
1. Yeah. So I'm going to take slices of W. So I'm going to take these 4 equations. I'm going to fix W. So W equals 0 is going to be the middle, and then we would see what these equations produce.
All right.
And then it should be symmetric because the equations themselves are symmetric, right?
Yeah.
So we'll just look at W going from 0 to 1. Any guess? So you think we might see a cube? Okay.
So maybe we could see maybe like a 4-dimensional rhombic dodecahedron.
Maybe just a rhombic dodecahedron.
Okay. Well, maybe we'll see a 3-dimensional rhombic dodecahedron. We'll take a slice of our 4-dimensional space.
Yeah.
Okay.
Maybe we'll see some like 3-dimensional like pyramid shapes.
Ah, maybe we'll see some pyramid shapes like we saw with the cube.
Or they might have square bases just because the rhombic dodecahedron is more related to this. Like it has a cube inside it, so you might see some squares.
Okay. All right. Well, let's go upstairs and take a look.
All
All right.
All right.